Yes, Garga, I'm audible to you. Yes, I'm audible. I'm audible. आप सुन पा रहे हैं मुझे?
Yes, yes.
Yes, have you completed all point?
Yeah, I am revision. I have started studying about the point you have told, and now I am studying about the spectroscopy.
Okay, no problem. Basic point. First, today only. Yes, no. Yeah, let me start first of all. Basic introduce yourself.
Okay, so my name is Vargo Mandal, and I am from Murshidabad, which is in West Bengal, and I have graduated from Vishwabharati, a central university in West Bengal, and then did my masters from IISc, and now I am preparing for GSI and appeared this interview this year.
Yes, good. Your name is Garga. What the meaning of your name?
Okay, so the meaning of my name is actually Garga in Bengali. It means the eating.
Eating.
Yes, yes, eating.
Yes, any antonyms, synonyms in your name?
Antonyms, what you told? Antonym, synonym.
Yes.
Uh, so this there is in the according to the grammars of Bengali, there is no such word like Gorgo. It's a name. It's a name only, that which is also the name of Krishna's guru. But the actually that comes from one protype which is present in the Bengali grammar, that is goi protype. So there is the for pratyay in Bengali grammar, there is no antonym synonym of pratyay, because that's a grammatical things, and that will appear as it is, as an independent entity.
Yes, good. Next is what's your strength and weakness?
Strength in chemistry, or what else?
Your life, related in your life.
Okay, so in according so for in my life, the strength is like my family is my the only strength, and the weakness is like my depression and frustration. That is my weakness.
Yes, good. Next, your hobby is gardening.
Yes, yes.
Yes, can you describe your hobby? How to use it in a day, week, month?
Okay, so in each day, like it's very simple. What I can do in the morning, I do the watering of the all plants whatever present in my homes, and along with this, in evening, I do add some what fertilizers to them, if whichever it is needed to them, as well as if there is any insects come appears there which is actually damaging my plants, I used to use the bio insecticides, which don't affect the environment but still kills the those harmful insects, as well as, and by this way, and mainly actually I've mainly focused on the flowering plants, and mainly in the winter gardening I focus, but still alongside I used to plant and the fruit trees also in my in my garden.
Yes, good. Next, point number two, your native place. Your district is Muridabad and West Bengal. Yes, no? Murshidabad. Yes,
Murshidabad, yes.
Murshidabad. Yes. Yes. Next, move on your district. How do you feel about your district? What the basic history of your district? Describe it.
Okay, so
Points from your.
Murshidabad is actually, according to the history, Murshidabad is a very famous place in terms of the medieval history, because Murshidabad is the place where the first battle of Palashi happened. So and that means that at first in British invasion happens here only as a ruler, not as a not as a East India Company's his business. So here only Lord Clive came to and do the war with undergoes war battle of policy with Sirajuddaulah, and because of the betrayal by Sirajuddaullah's as soldiers, mainly by Mirzafar, he got killed, and Clive owned the whole estate, like the Nawab estate of Bangla, Bihar, Odisha, and then only the Kolkata will be established as a capital of India. After that, that will be shifted to Delhi, but the first capital of India is in Kolkata.
Yeah,
And along.
You said 1910.
Yes, in 1910.
Is what the role of your district Murshidabad in West Bengal? What the major role?
Okay, so Murshidabad is famous for nowadays. It's famous. It's have the Murshidabad has the border, the gate Farakka gate on the Ganga that actually used to generate the electricity by NTPC over there. It has almost 5.12 kilowatt of electricity generation from there, and that is the major role of Murshidabad, and not only that, there is a place called Sagordip. That Sagordip is famous for the with the different types of vegetable production as well as the paddy production.
Yes, good. Next, move on West Bengal. West Bengal state. Yes, how do you feel about your state? What the basic history of your state? Describe one by one point. Political, economical, geographical, agricultural, cultural. Describe one by one point from your side.
Okay, so West Bengal, this. So we all know that West Bengal is culturally very rich in terms with respect to the other states. It's a very culturally rich state, and culture. There are so many of culture heritage is there in heritage, and also in politically also nowadays it is very famous. But and for the economy for West Bengal economy, that is mainly depends on the agriculture, mainly paddy production. But according to the government report nowadays, that one of the major or GDP producer is basically the our drink in what is called that alcohol industry, alcohol also, but and in politically, the first woman chief minister, that is Mamata Banerjee, is our chief minister from 2011, and there is a and he and from last 2 years he is she is the major, she's party like TMC is the major owns the majority in the each election, each MLA election, and not only that, in cultural it is very rich. Like there are so many of famous festivals, specifically Durga Puja happens there. Not only that, alongside with it is it's also known as the Kali Kshetra. There are so many Kali temples is there. That's why Diwali is also celebrated over here. Not only that, there is a Bengali culture which is called Bengali New Year, that is in the that is according to the Bengali calendar, that is called Nabavarsho, and also there is one is called Makar Sankranti at the end of the Bengali calendar. So it's culturally also very rich, and and that not only that, it is very famous for exporting. Like it always shows the surplus on the service sector. In that means that actually means that there are so many of peoples there are so many peoples in West Bengal who actually travels abroad as well as the other states of India for the different jobs and their works. That's why it always gives the surplus on service. But still now it is not that much efficient in manufacturing. That means the industry is not very good over here.
Yes, good. Next, what the main major role of West Bengal in our country, India?
Okay, so in terms of what? Sir?
Major role: economic, geography, polity, economics.
Okay, so it's actually it's a completely depends on the agriculture. So it's a major one of the second after Punjab, it's the second exporter of the paddy. And not only that, in West Bengal, that is also famous in terms of the border security of India, because there is one region which is called Siliguri corridor, which is which having the length of 27 kilometer, which always be a very important point in terms of defense, because if that point is actually correlating India, like the other part of India, the whole part of India with the northeast region. So if it is get cut down, the whole India become like the whole northeast region, all the 7 states they over there will be become are not able to be connect with the India. So in terms of that's why there are so many of like IB intelligence department, like from America it is CIA, India that is raw, that are so many is so much active over there. So in defense in terms of defense also, like internal in terms of external security, external affairs, this West Bengal strategic position of West Bengal is also very important, that Siliguri corridor.
Yes, good.
Hello.
Yes. Next, move on point number third. Point number third related to laboratory part. Yes. What is lab? What the role of laboratory in your life? Describe.
Okay, so lab like laboratory is like the room or the place where we fundamentally prepare something to to do well for humanity. So that is very much that laboratory is in laboratory we used to, like in chemistry laboratory we used to prepare so many of compounds or do the measuring of many things, so that that would be useful for human and life.
Yes. What the application of laboratory and what are the safety rule for laboratory?
Application of laboratory, like in if we consider in terms of the physical, like in chemistry lab, so there are generally the synthesis for in organic chemistry lab we generally used to do the synthesis of organic molecules and their separation, as well as the purification and the characterization by spectroscopic techniques. And in inorganic laboratory generally nowadays they are working on the preparation of different complexes and their usefulness or in catalytic activity, like for the synthesis of other organic species. In physical laboratory generally we do the rate measurement of any different reactions and the mechanism and the mechanistic study, as well as the DFT calculation, etc. And in material science or materials laboratory, like used to prepare nanomaterials, biologically active materials, those will be helpful for which will be going to be used for different human beings.
Yes, good. Next, first is basic is laboratory point is uh, qualitative and quantitative analysis. Yes. What the difference? Qualitative and quantitative analysis.
In qualitative analysis generally, in a sample we used to detect what are the different cations and anions present in that sample. In quantitative analysis, we used to know how much a certain metal or a certain species is present in that given sample. So that is the basic difference between qualitative and quantitative analysis.
Yes. How to identify the color order in a lab?
How to identify
Color and order in a lab.
color?
Color and order.
Order means the reaction order.
Order means smell.
Oh, order. Okay, so Color would be determined half. How to determine color? So color generally, if we get any colorful compound, generally we used to do the UV visible spectroscopy to determine in
Yes.
and for like if it is visible, then we will do the UV spectroscopy. But in terms of order, generally we smell, but nothing like any instrumental. I don't know.
Water is the smell of the ammonia, smell of the H2S, so H2S.
Yes, that only just
Observation,
that we can
observation.
only smell.
Yes,
Yes.
observation. Identify from the observation. Yes, how to differentiate acid base in a lab?
How to differentiate acid and base in a lab? So that would be differentiated by pH only. Like we will detect,
Any
we will
test?
try first first we will do the pH, like we first we use the pH paper and then check what is the pH of the solution in average. Then we'll look and the by pH like by pH meter we can determine exact pH of the solution by test. What you are asked by test?
Yes, any test? Flame test. What the purpose of flame test?
Flame test is used to determine in the alkali metals by just observing the flame color. And that is happened because of there's the last electron of the from of the alkali metals which is weakly bound that got excited to the higher energy orbital and get when it comes back is release the energy in visible region, and that light will be shown in the flame. That's why we can able to detect those alkali metals by the flame test.
Yes, cation and anion.
Cation. So for differentiating the cation anion, we have to use the electrolytic cell. So electrolytic cell cations will move towards the cathode, which will be which have the higher, which have the electron and which have higher number of electrons, or which does have the excess electron, and anions will move to the anode, which have deficiency of electrons.
Yes. Yeah, next move on. Qualitative and quantitative analysis is basic point is elemental analysis. What is elemental analysis? How to detect element in a lab? Nitrogen, sulfur, halogen.
Element in a lab, particular element for like if we have a sample, so like whole procedure how we'll move to just like what is the specific element present. Hello.
Nitrogen, sulfur, halogen. How to detect nitrogen, sulfur, halogen in a test? Test for nitrogen.
Okay, test for nitrogen is what for halogen, like if we have the halogen, like if we have the halogen, then we can do the
Halogen test
actually
is silver nitrate test.
but that is the halide, right?
Halogen test.
Hello.
What
But
halide?
that is the halide.
What halide?
Halides are like the reduced form of halide.
Yes, this test for halide.
Which test? AgNO3. If you add AgNO3, it will give the AgCl precipitate and AgCl precipitate, like AgX precipitate. And then differentiating the
Layer
each
test.
halogen.
Layer test. What is layer test?
Layer test.
Yeah, layer test also for the halogen test.
What is that? I don't know.
Okay, no problem. You look them. You have to study about elemental analysis. Yes, sir. Nitrogen test. Nitrogen test first determine the how to prepare for Lessine solution, sodium oxide solution. Do you know sodium
Mm.
oxide and Lessine solution? How to prepare it? How to make it?
Yeah, that I know.
Yes, explain.
First, we have to take the elemental sodium and then we have to burn it for in the test like the fuming tube, and then just we have to paste it by mortar and pestle and prepare and like then what I have to add? Then we need to add, is it at H2SO4
Yes,
and add H2SO4 to make the solution, and then you have to use to detect it like that. You
detect
have
through
to
nitrogen test. Nitrogen test with ferrous sulfate. Yes, no. Test for sulfur. Sulfur is test is lead acetate test, sodium nitroperoxide test,
sodium
peroxide test.
nitroprusside.
Yes, and test for nitrogen and sulfur present together. So test with FeCl3.
Okay, I have to read it actually.
Yes, you look them. You have to study about the elemental analysis. Yes, no.
Yes.
Next is basic point is boiling point and melting point. What the basic difference? Boiling and melting point.
Okay. Yeah. Basic difference like the boiling point and the melting point. So the boiling point is the point where where the liquid goes to the vapor state just without changing its temperature, and that then the melting point is the specific temperature, the specific point where in the phase diagram where the solid goes to the liquid state without changing the temperature.
Yes, example is boiling point and melting point.
Example. So
Uh,
water's boiling point is 100 degrees centigrade and melting point is 0 degrees centigrade.
Next is functional group. What is functional group? How to detect functional group in a lab? Like first one is carbohydrate.
Mm, okay. In carbohydrates, generally there are OH like the alcohol, the hydroxy group as well as the CHO like aldehyde and keto groups. So these aldehyde keto groups will be detected by Osajon test, and hydroxide group may be the hydroxyl that will be like detected by like OH groups are detected by like first we have to do the perform the uh, like first primary, secondary, tertiary. So by H2, is it what that what secondary like the alcohol test? What is that?
Carbohydrate test is molit test. Violet color will be there. Yes. Next is aldehyde ketone.
Aldehyde can be detected by uh, 2 for the D2 for DNP test.
Yes, 2 for DNP test. Yes, right. Yeah, describe it.
So for DNP test, generally the group has like it's a hydrazine derivative, NH2 NH2 derivative. So that one of the NH2 will be is free, and one is with the 2,4-dinitrobenzene. So this that free NH2 group first react with in a specific pH called at pH 3.5. It reacts with the carboxy carbonyl carbon and carbonyl carbon by the electrophilic addition reaction, and then and then in the next step the again one another molecule of it will be like another so and then after that the nitrogen release one proton, and then the so as it release one proton again the nitrogen lone pair attacks to the carbonyl carbon and then and release so that it will release the OH group as a water and form C double bond N, that which is called what is the ketone like C double bond N, so type species which is is also known as imine species. So by and gives the color, and so because of that there will be like mainly orange type color formation happens if from the aldehyde and ketone because of the crystallization of this 2,4-DNP based complex 2,4-DNP based compound of carbonyl species. So this actually helps us to detect the carbonyl compound on carbonyl compounds like aldehyde and ketones.
Yes. Next is carboxylic acid.
Carboxylic acid.
Yes, how to detect carboxylic acid in a lab?
Is carboxylic acid. It can be detected by
Litmus test.
what test?
Litmus.
That would be. Is it by like litmus means that will do the color change? So, like blue litmus too.
Yes, because of their acidic nature. So carboxylic acid turn blue, litmus red. Color will be there.
Yes, there, but that one is there na NaOH species. Then like CO crystal formation, white color compound forms.
Yes, sodium bicarbonate test, fluorescein test for acidic, ester test for carboxylic acid. Yes, na, so many tests.
Ester test also, like that will give the fruity smell.
Yes. Next, phenol test.
Phenol.
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 C6H5OH.
So azo compound formation in neutral, acidic, and basic medium. First we will form the N2 like C2 C6H5 N2 species by addition of NaNO2 and HCl, and then that will react with another like imine and that will react with aniline to give the azobenzene, azoxybenzene, and diazo compound in depending upon the pH of the medium.
Yes, good. Next is alcohol test.
Alcohol, that one is I think Cl chloride. Sorry, HCl.
Ferric ammonium nitrate test. Sodium metal test.
Ferric ammonium
Nitrate. Red color will be there. Yellow to red.
One is there na, that which will differentiate the primary, secondary, tertiary. That one.
Alcohol replace the nitrate ion of ferric ammonium nitrate, changing the color of the sodium from yellow to red color.
Okay.
Yes, you talk about the primary, secondary.
Alcohol can be also segregated by adding the
alcohol are very weak acid. React with the only very reactive metal like sodium to from alkoxide, or relative acidity is tertiary, secondary, primary methanol. Yes, no?
Like by high esterification also we can detect.
Yes. And preferred for the detection of an OH group. And distance between the primary, secondary, tertiary alcohol. Alcoholic OH is also present in carbohydrate.
Yes, that is it. The alcoholic OH.
Next is ester test.
What?
Ester.
Ester test. Ester just by observation, like by the order we can detect, but not by reaction, and we can what we can do ester. we can make like we convert it in acid and then check the litmus or pH.
Yes, ester test is a Fagel test. Fagel test, hydrolysis test.
Hydrolysis that I told. Like, hydrolyze to acid and then check the pH.
Next is hydrocarbon test.
Hydrocarbon means is saturated or unsaturated.
Yes, both saturated and unsaturated.
Unsaturated can be by bromine CCl4 or bromine water.
Yes.
MnO4 also we can do the unsaturated one. But the saturated alcohol, what we can do? So saturated what?
Yeah, no problem. You look them, you have to study. Yes, no. Your big point is laboratory part. Yes, no. Next is nitro test,
Yes.
amide.
Okay, amide NH3. So maybe by rearrangement like Beckman, Lausanne, those type of tests.
Amide is a Viret test. Yes. Amine test is action of nitrous acid. Yes. Nitro compound test is Mulken-Werker test.
Okay.
Yes, good. Next, move on. Point number third. Point number third is volumetric analysis.
Okay.
Volumetric analysis. What is volumetric analysis? Volumetric analysis first two basic point is titration and indicator.
So in volumetry analysis is like the like in a sample determining the amount or quantity of a particular metal or particular species is in terms of the in terms of the in terms of titration. The in proper measurement of the titrant and titrate.
The titration is three types: acid-base titration, redox titration,
Acid
complexometric titration. Describe one by one.
acid-base titration in which the titrate and titrant both are acidic or basic in nature. If we like for acidic, for if the sample is acidic, we used to use a standardized base is for determining the quantity of acid. For acid, or if it is a base, then we have to use the standardized acid to determine the base. And next is complexometric titration, in which a metal ion will be detected. An amount of metal ion will be detected using a complex chelating ligand. Mainly, here we use the EDTA as a chelating ligand, which actually hexadentate ligand forms octahedral complex with the metal ion, and that way that by this chelation, by direct or indirect way, we can able to detect the metal species, or uh, if the amount of ligand or the quantity of ligand is unknown, then also we can use the standardized metal solution to detect it. Then redox titration in which we used to do the we have to not give a look over the redox potential of the species, so that it can undergo the redox reaction with one another. And if in this case maybe the redox potential not comes under the range, but in that case we have to use the acid or base is to reduce the formal potential, so that reaction can happen in titration. And
Yes.
another
Next is indicator. What is indicator? How many type of indicator?
okay, so Indicator is the species or the mainly indicator is mainly the a dye species which can change its color at the end point of the titration.
Yes. Next is
And
EDTA titration. Do you have any idea about EDTA titration?
yes, in EDTA titration, we have to use the standardized EDTA solution to detect the unknown metal sample. So here EDTA reacts with the metal to form the metal EDTA complex, and from there we can able to if the EDTA amount is known, from there we can able to determine the amount of metal present in the solution. Here basically we use different types of like sorochrome black dye, erychrome black tea, these types of indicator which will be used for this titration. And all the EDTA form the complex with metal center, then those weakly with those weak ligand undergoes indicator acts as a weak ligand to undergoes complexation with metal to give the product and to give the color change at the end point.
Yes. Next, 4 point. 4 point is gravimetric analysis. What is gravimetric analysis? Describe it.
So gravimetry analysis is a process in which we can able to just by we have to do the complexation of a metal, not complexation of it. So we have to first form a compound of the unknown metal or unknown metal species, and then we have to use to dry the species sample, the formed compound, and measure the weight of the sample to measure the weight so that we can able to determine the quantity of the metal present in the unknown sample.
Yes. Gravimetric is first basic point is precipitation. What is precipitation?
So precipitation is a process in which precipitation is a process find the solubility find the solubility of a formed complex or formed compound and is less than that of the solubility product of that particular species, then that and process that compound or complex undergoes precipitation in the solution.
Yeah. Next, 5 number point is instrumental analysis. Yes. Which type of instrument you have used in your academic career?
So I have used mainly in my academic career, I have used mainly 4 instruments. One is NMR, IR, and then what that is called ACM, TACM, a few amount of TEM, and mostly the fast I have used the rheometer.
Yes. IR, UV, NMR, HPLC, chromatography. Can you describe it one by one?
HPLC chromatography, like I have not used, but I have to read sometime those two, like those things.
IR,
And
NMR, UV.
yes, IR, NMR, UV, I can explain. So in IR, yes, in IR generally, this is in IR means this is infrared spectroscopy in which the a particle or a molecule will be excited from lower vibrational its ground vibrational state to the comparatively higher vibrational energy state by infrared radiation, in which so because of so by this way, so the so this is basically the way of this is a way of quantum and mechanical analysis of bond vibration. So this so by this excitation the bond get so the bond vibrates, and by this excitation the bond vibrates, and that appears. And because of this bond vibration, and there will be the absorption of the infrared light. And so the transmission, the transmitted light due to after passing through the sample having the lesser intensity than that of the incident light from that. And so from this ratio of the incident light and transmitted light, we get the percentage transmittance for this particular species, which will be plotted in the plotted in the frequency domain just by Fourier transform from the time domain to get the IR spectra. Next is UV. UV, in which we generally use to detect the wavelength in which a compound get excited in from one lower